Hi everyone, so this video is going to be the introductory video for our probability unit this year. So first off, with a little bit of background about probability. So as you can see here, we've got probability is the event, the probability of an event is the chance or likelihood of that event happening. Probability is probably a word that you're familiar with in different contexts. You might be familiar with it in terms of weather, like the probability that it's going to snow or rain on a given day. You might be familiar with probability in terms of sporting events, like the probability that a team is going to win. You may be familiar with probability in all kinds of situations, but what it boils down to is it is the chance or likelihood of an event occurring. So probability is measured on a scale between 0 and 1. So at the bottom end of the scale, we have an impossible event taking place. So that event has a 0% chance of happening. It is assigned a probability of 0. So that doesn't mean like how maybe teenagers today might say that's totally impossible, that could never happen, and exaggerate. When you're talking about impossible in terms of probability, that actually means no chance. That has 0 chance of happening. On the other end of the probability scale, you have a certain event. That event has a 100% chance of happening, and it is assigned a probability of 1. Everything else falls between those two, somewhere between 0 and somewhere between 1. So if you're working out the probability of an event happening and you get a negative answer, for example, or an answer that is greater than 1, that is not possible. So probability goes from 0 to 1. You can talk about probability as a decimal. You can talk about probability as a fraction, and you can talk about probability as a percent. So obviously when you're talking percent, you're talking 0 to 100. When you're talking decimals or fractions, that's where you're going from 0 to 1. And then there's this sort of scale broken down here. So we use pretty common words when we're talking about probability, things like unlikely and likely, and then everything else is sort of in the middle. So on the low end of the scale, we go from impossible, which we already talked about, has a probability of 0, all the way up to, on the other end, a certain event, which has a probability of 1. Right in the middle here, we've got a 50-50 shot. So 50-50 chance, equally likely that that event will happen or not happen. And then from there, as you get closer to 1, you're getting slightly more than a 50-50, and then you're into the neighborhood of likely, and then all the way to highly likely. So these are not words that are exactly associated with particular probabilities. They are more like overarching general words that we would use. And then moving down from 50-50, we get slightly less than 50-50, and then unlikely, and then highly unlikely. So the closer you are to 1, the more likely something is to happen, and the closer you are to 0, the less likely that thing is to happen. So that's just a bit of terminology that we would use. So for example, if you want to talk about the probability that it's going to rain tomorrow. So let's talk a little bit about notation first. So when we're talking notation for probability, we use a capital P, and then in brackets, we write the event that whatever it is that we're trying to find the probability of. So we might say probability of rain tomorrow, according to the weather forecast, is 0.9. So based on this scale that we have here, I would classify that as highly likely, meaning I would bring my umbrella because it is highly likely that it is going to rain. Often you will see probability, the events, so this is referred to as the event. You will see those use capital letters to denote them. So maybe the probability of rain, so that our capital R might represent the event of rain. This notation is really important. When you're doing probability questions, you cannot just have numbers appearing out of nowhere. This notation of P and then in brackets, whatever it is we're finding the probability of, that is what gives the number, in this case the 0.9, meaning. So it is essential. You need to have that. Okay, Moving on. So now we're going to talk about the complement of event, and I want you to pay really close attention to the spelling on this. This is complement with an E, not complement with an I. So complement with an I is like, you look really nice today. That's that kind of compliment. Complement with an E is more like something that goes really well with something else. So you might say, wow, that color complements your eyes, meaning it goes well with your eyes. Or you might say, you two friends really complement one another. You go well together. That's what I want you to think about when you think about the complement of an event. So the complement of an event, when we're talking probability, is the probability that that does not happen. So we use this notation of E, and that little straight apostrophe is known as prime. So E with that straight apostrophe, we read that as E prime. That means the complement of E. So for example, if our E event was that it will rain, then our E prime is that it will not rain. You have to be a little particular about this. The complementary event to it will rain is not that it will be sunny, because there's a whole lot of other things that could happen other than rain or sun. So you have to get very particular. The complementary event is the event that first one will not happen. When we talk about the probability of complementary events, we notice that if you want to find the probability of a complementary event, you can find that by doing 1 minus the probability of that given event happening. So on the previous page, we were talking about the probability that it was going to rain. So if we know that the probability of rain is 0.9, so probability of E, or let's do this actually. So let's go E is rain. And then we'll erase this. And then, so probability of E is 0.9. E prime is that it does not rain. So the probability of E prime in this case is 1 minus 0.9, which is 0.1. So the probability that it will not rain is 0.1 if the probability of it raining was 0.9. So these two events, these complementary events, they add up to 1. Because it is a guarantee that one of those things will happen. So it is certain that it will either rain or not rain today. There is no other option. It's either going to rain or it's not going to rain. So one of those things will take place. So that's why the two of those, so the probability of a given event plus the probability of the complementary event, they add up to 1. And that's how you can figure out the probability of a complementary event, by taking it away from 1. Okay, so that's complementary events. So let's look at a question here to kind of pull all of this together. So we've got Lionel here writing an English exam, and the probability that he will pass his English exam is 0.93. So the first says, use a word or phrase to describe this probability. Okay, so the probability that he will pass is 0.93. So we think again about probability on this scale from 0 to 1. The closer you are to 1, the more certain it is that a particular event will take place. 0.93 is pretty close to 1. So if we go back to our little sliding chart here, as we're getting close to 1, we would put sort of 0.93 in here. So that falls in the category of highly likely. I didn't need the chart to do that. 0.93, very close to 1. So we would use a word or a phrase, so I would describe that as highly likely that Lionel will pass his English exam. And then part B says, find the probability that Lionel will not pass his English exam. So there's only two choices here. Either Lionel passes or Lionel doesn't pass. So those two events would be considered complementary. So the probability of passing and probability of not passing, those would be considered complementary. So because they are complementary, if we want to figure out the probability of, let's use a capital P for passing. So if we want to figure out the probability of the complement of P, so P prime, then we're going to do 1 minus the probability of passing. So 1 minus the probability that he's going to pass is 0.93. So when we do 1 minus 0.93, we get 0.07. Now it doesn't ask us to describe this with a word or a phrase, but if we look at the previous question and it said that it was highly likely that he was going to pass, then I would say it is highly unlikely that he will not pass. 0.07, very close to 0 on that scale. So that would be a highly unlikely event to take place. Okay, and that wraps up this video.